questions of chapter 4 start out with a contingency table. So give me the numbers, and give me what's the variable here? What's the variable here?
Good and bad, and they're wafers.
Good and bad wafers.
And then no particles, and that's the condition of the dye. The dye.
Dye condition.
And then the numbers.
No particles. So again, we're talking about, I guess, manufacturing computer chips or wafers, because the chips are made out of on a big wafer and they break them up into little chips. And they're either good or bad, and sometimes they're bad because there's particles on the chip, and sometimes no particles are bad anyway. So no particle. And you realize, of course, we can put the particle, no particle there, and just reverse it, but that's technical. And what's the numbers that you do?
320, 80.
80?
320, no, going down, sorry.
Okay.
That's 14 right there.
And that makes there's 400 of these guys with no particles.
Right, and then 14, 36, and that makes 50.
That makes 40, 50. So there are 450 particles in general. There were 334 good particles, good wafers,
And
good chips.
116.
And 116, and this adds up to 450. So this is going to be the foundation of the first part of the problem. And from this we can answer all the questions of the chapter, all 40 points of the chapter, which we're going to do right now. Okay, so let's answer all the questions. Remember,
Okay.
the first question is, what's the chance of a simple event meaning a single variable? Remember, a compound event involves two variables.
Well,
What's the chance of a good particle? Now, imagine if all a good wafer. Well, there are 450 wafers. You pick one at random. There are 450 chips. Some of them come from good wafers, some come from bad wafers, some have particles. So there are 450. I guess these are chips. You pull one out random. What's the chance it's a good one? Well, there are 334 good ones out of 450 possibilities. So the simple probability, of course simple for it involves just one variable, is going to be 334 out of 450. Now, on the online, sometimes they make you reduce it to a decimal or whatever. By the way, I'm not sure if anybody in this class complained, I think they did, that sometimes they ask you to take it out to 4 decimal places, and even though you're right, you messed it up and they marks it wrong when it really should be marked right. So I found a way to change it example by example. So it takes a long time to have to change every single number to 2 decimal places, plus I have to throw in something called a tolerance, meaning that it allows you to, if you're off by 1%, it still marks it right. So when you do it, that should hopefully solve that problem that some of you were having, but please let me know if it continues to happen. The next probability is the probability of not being a good particle, which of course means the probability of a bad particle. You can either do it directly, bad is 116 out of 450, or you can do it as 1 minus the chance of whatever this decimal was, 1 minus 334 out of 450, which happens to be 14 out of 450. I'm sorry, what did we do? 334.
what?
No, 116 out of 450. Whereas if you play around with the fractions,
Oh.
you're looking at other. This is the remember, this means the opposite of good. The complement. The word this is called complement. Complement is a fancy name for opposite of this context. The complement of good means the opposite of good, which means bad in a sense. That's the easy. Okay, this is your review, guys. So if you have a question, you please feel free to ask me to repeat something. The next probability is the chance that it's good and, let's say, no particle. Brian, how far can you see on the board? Tell me when to stop. Where my hand is?
You can stop it.
Okay, and I guess on this side of it goes as far as,
Right there.
okay, try to keep it. Okay, now, there's no formula, there is formulas for this, but we don't need a formula. We say basically how many are good and no particle. Well, these 320, I don't want to mess it up too much. 320, that's how many have both characteristics, and, meaning joint. It's called the joint probability. It's not simple, a compound is sometimes called. And for those of you who remember your set theory, it's also the intersection. You're looking at the intersection of one set of characteristics with the other set. And either way you look at it, the answer is 320 out of 450. That's that. The next question is, what's the probability of good or no particle? Well, here already we can do it two ways, once by common sense and once by formula. Common sense is basically how many people are in the good category, how many chips are in the good category or the no particle category. It's all of these. It's everybody except for those 36. So the answer should be 14 plus 320 plus 80, which is 414 over 450. So the common sense answer we'll put on the left side, 414 out of 450. But the formula says to do it by a three-part formula. First you figure out the good by itself, which is easy. You add to it the chance of no particle, which is equally easy. But then because it's double counting, we have to subtract out the people or chips count twice, which is both good and no particle. And plugging numbers in, the answer is going to be good, we said before, was 334 out of 450. No particle was 400 out of 450. And the overlap was 320 out of 450. And the difference should be adding, this should come out to hopefully 414 out of 450, is that right? Yes, it comes out to 414 out of 450. And again, if you want to change this into a decimal, you're welcome to. I'm not sure if the course compass or the MyStatLab wants you decimals or fractions. Decimals is pretty easy. Yes, Alicia.
I just want to know,
Before I forget, just like the or was symbolized by the and was symbolized by the intersection, for those you still remember your set theory, the or is symbolized by the union. It's just that's for those who don't know what I'm talking about, ignore that, but for those you do know, you realize we're talking about the union of two sets. Now, Adiza, please repeat your question.
oh, okay.
Right? What was your question?
Oh, never mind.
Okay. Now we're up to the next question is, I guess we can write it over here. What's the probability a particle is good? But now we're told further information, supposing or assuming or given. Let's say given is the typical way, but supposing is used by the book a lot. Given that we're talking about a particle, this guy definitely has no particles. Now, if something has no particle, there's a better chance that it's a good, a low is 334. But, well, I'm not so sure it's true. But you might think, if we know for a fact that this particular chip had no particles on it, maybe there's a better or worse chance that it's a good chip. So that's the conditional probability. Again, we can do it twice, once by common sense and once by formula. The common sense is the following. If we know for a fact there's no particles, that means we're talking about these 400 people, these 400 chips which have no particles. So among those 400, how many are good? 320 out of 400. So the so-called common sense answer is 320 out of 400, which again, for the course compass, you may have to change into a decimal, but for us, it's better to have it as a fraction. Before we go any further, is there any question about this first somewhat sophisticated calculation? Any question about why the answer to this question is 320 out of 400? Well, now, if you don't want to do it by common sense, do it by a formula. The formula says you break it up into two unconditional probabilities. First, a good and no particle. In other words, you take the two variables and you add them, no particle. And you divide it by the bottom one, which is, the one to the right, no particle. You just have to remember that's the pattern. If you reverse it, of course, you're going to get the wrong answer, no particle. Now, in terms of numbers, the top number was good and no particle. We said before someplace, good and no particle was 320 out of 450. He said no, both of them together, 320 out of 450. 320 out of 450. The bottom one is no particle, that's 400 out of 450. But again, there's no vertical line here, so we're not dealing with conditional, we're dealing with the whole sample space. So 400 out of 450. When you do your inversion and multiplying your fraction, dealing with fractions, this will eventually cancel. And the final answer is 320 out of 400, which is the same as the common sense answer, 320 out of 400. That's next to the last formula of the chapter. Any questions so far? The very last formula, which really puts it all together, is does this particular variable have any impact on this variable? In other words, does the die condition have an impact on the wafer? I guess it goes in this direction here. Does the die condition, the particles, does that have any impact? Well, it's hard to tell from the numbers. It's hard to tell unless you know the physics or how to manufacture these things, but we can try to tell from the following formula. If this variable had an impact on this variable, then those with particles should be doing better or worse than those without particles. That's the logic of this thing. If it has no impact, then it shouldn't be a difference. So the